Hello guys, Techalyzer here. I have something simple for you this time, but substantially important for any living space out there, especially now in the winter. I was watching a video on YouTube. It's this British YouTuber called BigClive.com. I think I'll link it in below in the description. And he kind of does these teardowns from time to time, and this time it was one of those scams, you know, with the power savers that are kind of the size of this watt meter, and all that scam, you know. It says that you just plug it in and it saves like huge amount of power, and all it has inside is nothing but something to... Well, damn it. I think that will survive. There's not much to be damaged by falling in this thing. Basically, all they have is just a circuit to power up an LED, so you can see that it's working, and that's it. But what caught my attention was because he also explained that if you do buy one of these, it means you have a reason for it, and it means you have a rather high electricity bill, and he gave some advice on how to lower it. Now, he didn't mention heating, but he was talking about electric heating, you know, those boilers that heat up water with a heating element. I don't have that right now. Thank God I have a gas central heating system now, because I've moved from our capital city. If you don't know yet, it has some major problems with heating, and yeah, it's really everything in a capital city is basically just going down. It's no longer a place where you want to be, so you basically were left without... We wouldn't have had heat this winter in like minus 15, minus 20 temperatures, and that's a lot of people are sleeping with sweaters on and winter hats on and all that kind of stuff. Anyway, now I have a thermostat I can set to whatever temperature I want. It's at 22.6 now. I don't know about you guys, this is cold. This is cold for me. Which is precisely why I opened the window a bit earlier, so I can have the thermostat turn on the heating. You know, even if he was talking about electric heating, I thought, well, this thing has electric parts in it. It has the pump right here, you know, it has the electronics, it has the exhaust fan. It does have a few electric and electronic stuff inside that can draw some power, but I don't really know how much. I mean, I don't know if it's 50 watt, 100 watt, 500 watt. I have no idea. I noticed that once it gets the water at the temperature you set it right here. This is for the hot water, this is for the heating. It's around 60 degrees now. Once it reaches that temperature, and once it reaches the room's temperature almost, because, you know, if you set 24 degrees, you won't have it stop exactly when it reaches 24, because you'd still have like boiling hot water in the heaters, and you'd end up with a much higher temperature in the room. So what it does, it reaches, I don't know, somewhere around 0.2 degrees until, below the temperature you have set. Then the gas stops, and that's when just the pump keeps recirculating the water, and basically just recirculating that hot water that has just been heated up by the pump, how can a pump heat water? So it just keeps circulating that until you reach the set temperature, and in the meantime the water cools down, because you know, there's no more burning gas inside. What can you do? I don't know. Setting a lower temperature, turning off system. Once you, I have no idea. I need to know how much current it draws in the first place, so I can have an idea if that's a problem or not. It never works according to plan, does it? Sorry for the aspect of this. It's been through some wall painting and can I make it a bit? Yeah. So I haven't really bothered to clean this extension anymore because it's, you know, it's old enough and messed up enough that it doesn't really matter. Let's see if we have, where should I put this? If we have power, and we do. I hope I can get a good reading on the camera. So, 211 volts. That's rather unusually low for our country. It's the lowest value I've ever seen in this country, actually, and especially in the city area. It's a bit low, you know, but most electronics are rated anyway with a bit of tolerance below and above those 230 that we have here officially. So now, there's this power button. I'm gonna flip it, turn on the heating, and actually let's set it on 209. Wow. Amp and watt. There you go, that's the watt reading. There we go, that's a bit better. So we have the thermostat at 23.3. It's set on 24. If I press this button, you can see it's set on 24. As soon as I'm gonna turn it on, it's gonna run the exhaust fan for a while just to make sure it pukes out any exhaust gases that might have been left in the heating system, and then it will turn on the gas in the pump. So let's see what happens. It's set on watts and turn it on. Okay, 50 so far. Is that just the fan? Gas turned on. And now it's basically just stabilized 106. I gotta say it's pretty damn close to what I estimated it to be. I thought it would be around 100 watts. Now I kind of tried to guess, you know, the PCB together with the pump and the exhaust fan. I estimated around 100 watts. That's a very close value. It usually doesn't happen when I try to guess stuff. 107, you can see this LED here indicates that the gas is turned on and burning, and you can see the temperature rising. 50, it's gonna go 51 now. And it's set to 65 actually, not 60. 52 is gonna go to 53. That's 106. I'm curious to see if it drops while the pump is working. I've seen pumps with like 3 stages, 3 speeds. I don't know, I have no idea if this is the case. I'm not opening up the heating system just for that. It's irrelevant anyway. I'm just measuring the consumption as it is. There's nothing I can change. So what I wanna do now is dial down the temperature, 23.6. Set it to 23 and see what happens. Now the pump is running. So I'd say it must be around 50 watt, maybe 55. still quite a bit of power, you know, if you are to consider a modern computer. I think there are times when I don't even reach 100 watts during the pump stops. And this is basically just the electronics now. The fan is turned off as well, so it's just the PCB and the central heating. 4 watts, that's 4.5, that's something, you know. I thought, for instance, the washing machine only draws about 1.6 watts. I'm not sure if there's anything else powered in there besides the PCB. That seems a bit high, you know. Not very relevant for you know, daily use anyway. It needs to stay plugged in to keep the heat going. I was just curious how much current it draws while it's working. I can turn on temperature up to 24 again. Whoosh, the fire is going. You can see about the same value. There's probably gonna be minor changes depending on the temperature and pressure in the water loop, but nothing too important. It's somewhere around 106. I'm gonna turn it off now. I don't know. It's not too much actually. It's not too much for actually this. Let's see if I can do something. This light bulb here, which actually I'm very curious if I can see the actual filament. Good enough for a camera as cheap as this one. This one is a 100-watt incandescent light bulb. But the thing with the light bulbs is that you would obviously have them turned on for the entirety of the period that you want to be lit up, that you want to have light inside of your house. So, you know, this is gonna be like hours every day. While this, you know, it only runs like for a few minutes, I don't know, half an hour at most, until it reaches the temperature, and then it only turns on like a few seconds during an hour to just keep the temperature going. So unless you're opening the window to get some fresh air, you're not gonna have much functioning time out of it. But anyway, as I told you, 100 watts is not that much. So there you have it. That's what one of these would consume. It's a small heating system. Here we have small apartments. It's somewhere around 24-25 kilowatt of heating per unit. You know, not the electric power, the heating power. It's not written anywhere on it. So, oh, actually, it has a label here, but what? It's magnetic, or I'm not ripping that up. It's we're tenants, and I don't know. It's somewhere around there, 24-25 kilowatt heating system. One of the smallest you can get, at least here. I don't know if you can get lower than that. Anyway, thanks for watching. We found out how much electricity the heating system consumes. It's 100 watts. The point is, it's low enough for it not to be a problem. You know, if it was like 1500 watts, that would have been an issue. 100 watts, not a big deal. Thank you. Thanks for watching. See you next time.